Hello, I welcome you all. The problem reads the 4 kg smooth collar has a speed of 3 meters per second when it is at s equal to 0. Determine the maximum distance as it travels before it stops momentarily. So it means when it stops momentarily, its velocity at that instant is equal to 0. Therefore, the kinetic energy is equal to 0 at that instant when it stops momentarily. The spring has an stretched length of 1 meter. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So the collar will have some weight, W, like so. We're assuming it's vertical. Okay. Assuming it is vertical, right? Okay. So what do we have? We are going to use the principle of conservation of energy. So we have A, we have B. This collar is moving from A to B. So let's define the lengths of these springs. This is one spring at that point. This is another spring at that point. So let's call this as LB. We call this as LA. So let's say LA is just equal to 1.5 the length. LB is equal to square root of s squared plus 1.5. Then L original is just 1 meter. Right, so the kinetic energy at A plus the potential energy at A is just going to be equal to kinetic energy at B plus the potential energy at B. So T, like we said, is the kinetic energy, and V is the potential energy, and we have two here, gravitational and elastic potential energy. So at TA, the kinetic energy is equal to, of course, it has some initial velocity mva squared, and then the potential energy, gravitational at this point. Let's choose the datum. I'll choose my datum to be this point like this. It's really up to you to choose which one is your datum. So this one, I'm calling it my datum. Okay. So if that is my datum, this just becomes 0. Then VAE, which is the elastic potential energy, is just equal to half K times LA minus LO squared. Then TB, at that point, the potential energy, the kinetic energy, is just going to be equal to 0, because we are saying momentary at rest, okay? Because it stops momentarily at that point. That's what we've been told, right? And then VBG is just going to be equal to minus WS, okay? And VBE is just equal to half K LB minus LO squared. Let's write all this stuff in one equation. So I'll have half, I'll leave out the zeros, VA squared, and then equals the plus half k LA minus LO squared equals minus WS plus half k LB minus LO squared. Let's put numbers. So half, the mass is 4 kg, VA is just 3 squared, plus half, the spring stiffness is 100, LM is 1.5, LO is 1 squared. The weight is just, we have a minus there, that is 4 times 9.81 times S plus half K, which is just 100. This is just 100, and then LB is just square root of S squared plus 1.5 squared, then minus 1, and everything squared. So let's write this. So we'll have 0.5 times 4 times 3 times 3 squared plus 0.5 times 100 times 0.5 squared. Okay, so this here we get 30. Let me write it somewhere here like so. I write it here 30.5. I just want to rearrange this. It's a plus. Then I take this, the other side is 4 by 9.8. This one is just going to be equal to a plus also 39.24 S. Okay, and then the other one, this is a plus 2. Let me see. This one I'll leave it this direction. So this I'll take it the other side. I'll take everything the other side. This one will also be a minus, and this will be a plus. Okay, so this just becomes 50 square root of, this is 50 square root of S squared plus 1.5 squared, okay, minus 1, and squared like that, then this is equal to 0. Okay, so then I'll need to solve this using the trial and error. I need to solve this using the trial and error. So let's write this equation. Where we go. Alright. So we said this is 15 plus, this one is a minus, that's a 4 by 9.81. And then this one here, we added the 2, which is 0.5 by 4 by 3 squared plus 0.5 by 100 by 0.5 squared, 30.5. Took it to the other side like so. So then we're going to say, let the function itself f of s be equal to 0, and this is just equal to a 50 square root of s squared plus 1.5 minus 1, okay, minus 39.24 s minus 30.5 equal to 0. Okay, Let me just move this. How come I can't move this? Alright. This is 30.5 equal to 0. So we said f of s is just equal to 0. Therefore, we have this function. So let's draw up a chart. Let's draw up a chart so that we find this value of s. Draw up a chart. We need to solve this using the trial and error. So this is my f of s, and this is my value of s, and this is my f of s. Here we are not sure of the domain, so we're just going to start from 0. We keep on increasing, so we are saying s is going to be positive, right? Let me just check one thing. Okay, 39.24. So let's say if s is 0, okay, if s is 0, then we have a 1.5 squared. Okay, square root of 1. So let me write this for equation 15. Open bracket, square root of 1.5. I just said 0. Okay, squared plus 1.5 squared. I close bracket. I close this. Sorry, I just close that. Then I say minus 1. I close, then square root, then minus 39.24 times that minus 30.5. So this it just gives us a minus 18. Let's say if it is 2, again we are looking for numbers. We should get a minus and a plus, then we know that the solution is in between. So we have minus plus. Once we get these two values, then we begin to do the iteration. You know, somewhere there the solution lies between positive and negative. Okay, so let's plug in a 2. So a 2. Alright, so there we go. Alright, there we have a 3.5. So we know somewhere between 0 and 2, the solution is in between there, 3.2. So the average of the two is 1. So you plug in 1 again. This is just one of the ways of solving this. You can use other methods. Okay, other simpler methods. So this is 37.52. This is negative. So we'll get an iteration between the smallest negative and the smallest positive. So half of that is 1.5. Okay. So let's plug it in. Okay. So it's 1.5. 0.5. Right. So there is a 50. Open bracket. Square root of that. That's 1 from 9. Okay. Right. So we have a 26.49. Let me just check something. Alright, what do I get? Alright, so let's get an average again of the smallest value between smallest positive and the smallest. So again it is 2 and 1.5. What's the average of that? I need another calculator for working out these values. Right, so I will have a 2 plus 1.5. 1.5 plus 2 divided by 2. That's 1.75, so 1.75. Let's plug it in. Okay, 1.75. 0.75. Alright, what do we have? We have a minus 14. It's reducing at a very slow rate. Okay, so again, there we go. Average of that plus 2 divided by 2. This is 1.88. Okay. 1.88. Okay. There we go. We have a minus 5.56. Okay, so we keep on average of these two. Okay, 1.88 plus 2 divided by 2, 1.994. Okay, and we have 94 on the other side, 94. So this one gives us a minus 1.17. Okay, there we go. 1.94 plus 2 divided by 2, 1.97. Let's plug it in like so. Alright, we have a positive 1.14. So these are now the smallest, negative and positive. These ones, 97 plus 1.94 divided by 2. So this is a 1.96. Okay, 1.96, and that one like so. So we have a 0.36. 0.36 average of the two again. 1.96 plus 1.94 and 6 plus 1.94 divided by 2. This is the last value. Okay, 1.95. Let's check what we have. 1.95. So we do have a minus 0.41. So we don't have any value now. It will mean, of course, the solution just lies between 1.96 and 1.95. So we can go with the smallest value for now. This is this has the smallest error, and therefore let me just pick up a pen. Yeah, therefore S, okay, right, S not red, S is approximately equal to 1.96 meters. All right, I guess this is about it. Let me outline just this particular value. We have found the value of S. You can use a program if you want to. This is one of the method called trial and error method. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.